Hi, my name is Beverly Ma, and I'm going to be teaching you about geometric series and how to represent it with sigma notation. Before anything else, we have to know about or what a geometric sequence is. And basically, it's a sequence of numbers where the succeeding term is the previous term right before it times a common ratio. And so in this first one here, have this geometric series whose common ratio is 2 because, as you can see, you have to multiply by 2 to get the next term. And then the second one, the common ratio is -3 because 4 times -3 equals -12. -12 times -3 is 36, and it keeps going like that. And so that's how we get our common ratio. And if we want to represent it in a general format, it would be a times r, which is our common ratio, and then you will keep multiplying by another time of that common ratio. And so that's why that exponent keeps increasing by 1 each time you move to the next term. And so in the geometric series, you get that geometric sequence and you add all the terms. And so like in our first one, we would have 2, 4, 8, 16. That keeps going. But this time in the geometric series, you would actually have to add them. So 2 plus 4 plus 8 plus 16 keeps going since it's infinite. And then in our second one, then you do the same thing. 4 plus -12 plus 36 plus -108. And then if you want to represent it generally, you would have a plus r, a plus a times r plus a times r squared, etc. And then if it is a finite sequence, you would add up to that last variable, which we don't really know, so that's why we're representing it in the general format. So we would actually add up all the terms until a times r to the nth power. And then if you want to represent it with sigma notation, you write the sigma symbol and k, which would be our term number, the number of the term. It would start with 1, and so you write it below that sigma, and then it would go up to the nth power because that would be our last term. And it would be k equals 1 to n of a times r to the k minus 1. And you would write -1 because if you have a times r to the 1, or to the 1, yeah, it would just get a times our common ratio, which we don't want for our first term. As you can see, our first term is just a, and so we would have to subtract that by 1 to get 0, and it would leave us with a times r to the 0th power, which anything to the 0th power is 1, and so you just get left with a, which is what we want for our first term, and that's why we subtract it. And so in our example, we have this finite series: 5, -10, 20, -4, 80, and -160. And it's finite because it doesn't keep going forever, and as we can see, our common ratio is -2 because we have to multiply by -2 to get the next term. And so if we want to write it as a series, a geometric series, we would have to add up all of these values to get -105. And if we want to represent it with sigma notation, we would have to write the sigma. And I'm just going to list the terms so that it's clear. So as you can see, our first term is k equals 1, and our last term is 6. So it goes up all the way to 6 of this equation. 5 times -2 to the k minus 1, which we got from our general equation. And so that is how you write geometric series in sigma notation.